Hello all, welcome to Code Hub. Today let us solve the LeetCode daily challenge and the problem is palindrome linked list. Here the head of the singly linked list return true if it is a palindrome, else false if it is not a palindrome. This is a straightforward problem where we are given with a linked list. We have to check whether that linked list is a palindrome or not. So what we can do is first we can go for a brute force approach. For that we can just take an extra space for and store the value of each and every node into our vector, and once we have it we can do a two pointer approach, and we can check for both the values at the front pointer and the last pointer, and if so we will increment the front pointer and we will decrement the last pointer, and if the first and last equals comes equal, then we can say it is a palindrome, else not. So this is a brute force approach that we can do. But what will be the brute force approach time complexity and space complexity? The time complexity for brute force approach will be, we will first traverse the entire linked list and store it into an vector, so it will take an order of n. So it will take an order of n to traverse that, and then for checking another order of n, so we can say, we can generalize and say for it will take an order of n, but the space complexity is also linear. So when we tell this approach to our interviewer, they will not be happy because we are using an extra space. So what we if the interviewer asks to optimize this approach, what we can do is, we are given a linked list. So first we can think of what we are doing in a normal vector. We will be in a normal vector, we can check the first pointer and the last pointer, and if it is equal we can proceed further, increment the first pointer and decrement the last pointer. But in the linked list we cannot do that. That is the problem. We cannot access the previous node value. So what we can do is, we are given a linked list 1 2 2 1. If we are able to split this linked list into two halves, first half and the second half, and we are able to reverse the linked list of the second half, we will be having like this will be the first half and this will be the reversed second half, and now we can traverse this first value and the value of the first half and the value in the second half, and if it is equal we can go move to the next of the first half and next of the second half, and again we can check for their values. If it is equal we can move. Once we reach the end of the both the linked list first half and second half, then we can say that is going to form a palindrome. So this is the optimal approach that we can tell to the interviewer, but how we can yeah, implement this is going to be a tricky part. So first we have to split the linked list into a two halves. So for that we have to find the middle of the linked list. So first step will be find the middle of the linked list. Once we find the linked list, we have to split it into two halves. Once we split it, what we can do is, we can reverse the second half, of the linked list. Once we reverse the second half, we can step 4, we can iterate over both halves and check whether it is a palindrome or not, So this will be our steps that we are going to follow. But how we are going to find the middle of the linked list? We can use the hare tortoise method, where we can have a fast pointer and a slow pointer, and we can move the fast pointer twice ahead and slow pointer once ahead. and if this fast pointer reaches the null end of the linked list, the slow pointer will be at the middle of the linked list. So that way we are going to find the middle of the linked list. But there occurs a two case. The node will be, the linked list will be containing a odd number of nodes, and the linked list can be containing even number of nodes. So this is the two cases. So what we can do is, if we find the middle of the linked list, so consider we are having the fast pointer here for the odd number of nodes, and the fast pointer here for the even number of nodes. So we'll be also having a slow pointer here. I'm just doing a dry run so that you will get an idea how we are going to handle this odd number of case and even case. So first the iteration fast and fast of next is not null. So we will move fast of next equal to fast equal to fast of next, and slow equal to slow of next, and similarly we will move forward. Fast and fast of next is not null, so we will move 2 steps ahead, and we will move 1 step ahead. And now the fast and fast of next is not null. So now what we can do is, we are left out, we have now fast of next is null. So we will be breaking out of this loop, and the slow points to the middle of the linked list. This is the odd number of case. So but we our requirement is to split 1 2, and we have to split 1 2 and 2 1, right? So we don't want this 3, since it is an odd number, we will be having only one number, so we can eliminate that 3. We have to split 1 2 and 2 1 only. So we need some previous pointer here. So if we have some previous pointer in this place, we can make this previous of next to be null, and slow of next to be second head. So that's way we can do. So for odd case, what we have observed is, my fast of next is going to be null. Fast of next is null. This is what we observed in our case. This is the end condition. Why we are actually observing this is, this is the end case. So let us do for an even number of nodes, and we can see again the fast will move 2 steps ahead, and the slow will move 1 step ahead, and again the fast will move 2 steps ahead, and the slow moves 1 step ahead. You can see that when we are traversing this even number of nodes, we will come out of the loop when the fast becomes null. For even case, we are actually, for even case, fast itself becomes null. So this is our end case. So we are observing this, this is the end case for even number of nodes. So with this help, we can actually handle this odd and even case, how to split. So here if we have a previous node here, we can make the previous of next to be null, and the slow is automatically the head of the second linked list, second half's linked list. So this is what we are going to do. First, what we can do is find, step 1 is the find the middle of the linked list. Find the middle of the linked list. So for that, what we want to do is, we should have a list node fast, and which points to head, and slow, which points to head. While fast and fast of next is present, we will go inside the loop, and we will make fast equal to fast of next, and slow becomes slow of next. So by this way we have find this, we have moved the fast and slow, but we are also required to have a previous pointer here. So if my previous pointer is not there, we cannot take care the other cases. So we have a previous, we initially it can be null. So before moving the slow pointer, my previous will be pointing to slow, and then we will move the slow pointer. Now we have a previous node. So now actually we have to split it into two halves. So now how we are going to split, that's what we have seen, the odd case and the even case. So what we can do is, for odd case, the fast of next is null. If fast of next is null, if fast itself null, fast itself becomes null. If my fast itself becomes null, if my fast itself becomes a null, then this is for even case. Even case. For even case, what we have to do is, my previous of next will be pointing to null. My previous of next is going to be pointing to null, and before that we can make the second head point to the slow pointer. Else this is not the case. Fast is not null, fast is present having some node. In that case we have to do previous of next to be null, previous of next to be null. Before doing the previous of next, we can make this slow of next to be second head. Sorry, my second head equal to slow of next, and we can also delete this slow. So actually don't want to delete, we can have it like that itself. Slow of next and slow of next may point to null, and we can delete this slow as well. Delete this slow as well. So we have handled the odd case and the even case. Okay, now we have handled the slow and odd and even case. Now what we have to do? We have to reverse the linked list. So we can try to reverse the linked list now. Reverse the second half of the linked list. So we can actually call the second head with reverse function. Reverse second head. So now we can write a function private, it is going to return me a list node star reverse list node star head. So to reverse the function we need a 3 pointers, previous which is going to point to null, next which is going to point to null, and the cur which is going to point to my head. So now my while cur is true, we are going to point cur of next, before that next is going to be my cur of next, cur of next is going to point my previous node, previous equal to cur, cur equal to next, and finally my head is nothing but my previous, and return this head. So we have completed the reverse function also. After doing the reverse of the second half, what we are going to do is we are going to iterate this and check whether this is forming a palindrome or not. So what we are going to do is, now we are going to iterate over the both the pointers. So for that we can say while my head and my second head is present, if my head of var is not equal to second head of var, then we can say return false, or else head equal to head of next and second head equal to second head of next, and finally we can just return true. So let us try to run the code and then check whether we are getting it right. So list node fast and slow pointer, previous is null, so fast and fast up next we are checking. So we are I want to check for one base condition. If my head is not present or my head of next is not present, then we can just directly return true. Now fast and slow pointer are moved. If my fast itself is null, then my second head becomes my slow, and this previous of next is null. Okay, fine. Oh, we didn't declare the second head itself, so we'll also declare that too. Initially it is going to point to my null. Okay, let us try to run the code so that we may know where we have missed it. Sorry, second head. We get true for this test case. Let us try to run our code for other test cases as well. We got accepted. Let us try to give for different test cases, like odd number of cases, even cases, and 1 2 2 1 and 1 and an empty. Let us try to run the code here. Okay, invalid test case, because we are giving at least one node is present in our test case constraints. That's why we got an error. We can try to remove that empty test case. Now it got accepted for every test cases. Let us try to submit our code. It got accepted. Hope you like this video, and I have written some clean code so that you can verify it, and you can also apply the same thing to your interview as well. This is what they will be expecting. If we give this clean production code, it will be more no chance to reject at all. So hope you like this video. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.